Now let's look at some statistical functions. The first statistical function is average. As you might know, average is the total value or the total sum of a number of figures divided by the total number of figures. Let's say we had to calculate the average of all the sales for each year. One way could be to calculate a sum of all the sales values and then divide it by 1, 2, 3, 4, 5, 6, 7, 8, which is 8. So we'll just manually input 8. This is the average sales for all the years. Now let's use the average function to arrive at the same result. Average, select all the cells, press enter. So the average function very simply does exactly what we can manually achieve and calculate average by summing all the values and dividing it by the count of values. Let's delete these cells. The example before us asks us to go a step further and calculate a moving average. What do you mean by a moving average? A moving average here essentially means average of 3 years sales of the last 3 years sales. So let's say if we are looking at the average of the first year, since there are no prior years, it will just be the first year sale. Average of the first 2 years will be average of the first 2 values, sales values. If we move on to, let's say, third year, it will be 3 values prior to the third year, including the third year value. And if we move on to the fourth year, it will be fourth year, third year, and the second year. And similarly, we'll keep moving 3 values for each year after the fourth year. The formula asks us to create a formula to compute a moving 3-year average for the gross margin in the given example. As you might remember, gross margin is gross profit divided by the sales. So let's see, gross margin is gross profit divided by sales. Now let's look at how we can compute the moving average. Here, since we want a formula that we can copy across all the cells and we want it to be flexible enough to compute a 3-year average, what we have essentially done is equal to average. The first number should be 2 years prior to the current number. So 1, 2, and 3. Bracket close, enter. Let's format this as a percentage, add 1 decimal, copy this formula for all the values, and here we are. We have a 3-year moving average for each year's gross margin. Now let's look at average A. The essential difference between average and average A is that average A will treat all text values and zeros and a false value as 0, whereas it will treat true as a 1. However, average function will simply ignore any text values or true or false and only compute average for valid numbers or constants. As an example, let's simplify to say 20, 30, 10 and test. The average of these numbers is 20. Very simply, the average of these 3 numbers is also 20. However, if we use average A and select all these numbers, the average comes out to be 15. This is why, because average A has considered this value as 0. So if we replace test by 0, average function will also yield us 15. If we change this text value as true, true is essentially 1 for average if function. So if we replace true by 1, average function will also match to average A's output. Now let's delete all of this and move on to the next function, average if. You might remember SUMIF from the earlier functions which was found in mathematical functions lesson. Average if works on the same principle. Let's look at a very simple example. Row 51 gives us a simple average of all the purchase values. However, in row 52, we are using average if to compute a conditional average for only the male customers. How can we achieve that? Let's say we type average if, press tab. The first argument is the range. Just as we did in the SUMIF, since we need to evaluate customer purchase values only for male customers, we'll select the range with the gender. Criteria is to be a male. So let's say we select male. Okay. Remember to make it a fixed reference, because if you move down or copy this formula elsewhere, the reference might change from E40 to something else, which will not yield you the correct result. And finally, that is the average range, which is all these values, all the purchase values, and OK. Now you can see that the average for males that we've just computed using average if is similar to the example's output. We can calculate average for females in a similar way. Moving on to the next example of count. As the name suggests, count means to count the number of cells in a particular range or selection. In the example before us, the count function calculates the number of orders. Let's see how it works. Is equal to count, tab, select all the cells and enter. That is the counts. That is the COUNTIF allows us to set a condition, and that condition is evaluated for each cell in the selection. If that cell satisfies that condition, it is added or considered in the count function, otherwise it is ignored. In the example before us, we have to count the number of orders where the quantity was less than 100. If we do it manually, we'll just see that there is only one order with quantity below 100 units. Now let's see how we can achieve it through COUNTIF. COUNTIF, tab, we select the range as all the orders. Now the range, and it is important to note how the syntax for the range or a less than would work here. We put less than symbol in double quotes. Then we put an ampersand and 100. We press enter, and here we have the number of orders which are less than 100 units. Moving on to the next example of COUNTIFs. Here, much like COUNTIF, COUNTIFs also evaluates cells based on certain criterion and counts the number of occurrences. Only COUNTIFs gives us the option to have multiple criteria instead of a single criteria like we observed in COUNTIF. Let's see how we can use COUNTIFs to evaluate and solve the problem before us. The problem before us is to create a count formula for items which are less than 150 units, for orders which are 150 units or less, and separately for males and separately for females. Now let's look at the syntax of COUNTIFs carefully. COUNTIF's first argument is criteria range 1. You might be aware with this language, range refers to the range which we need to set a criteria for. So the first criteria is the number of units ordered in a particular order. Let's press F4 and make it a fixed reference. Then put a comma and the criteria. The criteria as per the example is that it should be less than 150 units. So double quotes, less than, ampersand, 150. This was the first criteria. Now we move on to the second criteria. The second criteria is males only. So we select the entire array for gender, F4, and the criteria range is male. We close, and there we go. Similarly for females, let's just copy this formula and change a small criteria, which is instead of males we make it female, and enter. So if we look at it manually, we'll observe that for males all orders below 150 are only 1, 2, 3 and 4, and for females orders below 150 are 1, 2, 3. This was COUNTIFs. Moving on to max and min. Max stands for maximum value and min stands for minimum value. As simple as it sounds, the function is very easy to model. Let's consider a maximum function. Maximum function asks for the numbers, and here in row 100, let's assume that we are evaluating the max of all cash and cash equivalents. So we select all the cells, close the bracket, press enter. 150 is the maximum cash and cash equivalent. Similarly, a minimum function will return the minimum value. Let's look at the example before us, which says create a formula using max and min function to calculate the possible dividend. Now, if you think logically, dividend cannot be negative. We will have to use a combination of max and min to consider dividend only when the cash flows are positive. Whenever the profits or the cash flows are negative, then we cannot distribute any dividends. That is the first criteria. The second criteria is we can distribute dividends only up to the maximum accumulated profits. Let's see how this formula and this function can be modeled to achieve the desired result. As you can see, in the first year, cash available was 50, accumulated distributable reserves were 100, so I could distribute a maximum of 50 as dividend. In the next year, since my cash went negative, I could not distribute any dividend. In the third year, 100 was my cash, but accumulated distributable profits were 150. So I could only distribute 100. In the next year, which is year 4, since accumulated distributable profits are only 50, although my cash is more than the profits that I can distribute, I will only be able to distribute the maximum of accumulated profits. And this goes so on. Let's try to model this. Is equal to the maximum we can model, the maximum we can distribute as a dividend is max of this or this, right? However, the second condition will also we have to satisfied, which is we can only distribute the minimum of the available cash equivalents or accumulated distributable profits. So we will further create a condition, minimum of these two, bracket close, comma. Now when you look at the formula that we've created, let's apply it and see whether it matches the output. We could satisfy the first condition, which was that we are distributing dividend lower of cash available or accumulated profits. However, in the years where our cash was negative, we obviously could not distribute any dividend. So in that case, we have to apply a maximum function of negative value or a 0. So let's edit our formula accordingly. Selecting all the cells, press F2, remove the last round bracket, comma, 0. Now what the formula reads as is, the first condition will be minimum of cash or accumulated profits, and the second condition will be minimum of those two or 0, and a max function. So a max function will be applied to a minimum of those two, which is cash or profits, and a 0. Let's apply it all across, and here we are. We have the desired result. Using a combination of max and min, we were able to achieve distributable or possible dividend during each year. Now let's move on to median. Median, as you might be aware, is a statistical function to find the middlemost value in a set of data or a set of numbers. So when the values are arranged from increasing to decreasing, the value which sits approximately at the centermost point of the data is selected as the median. The formula or the function is as simple as median. Let's put tab, select all the numbers, bracket close, and enter. And that is it. That is how we compute median. Now let's look at some logical functions. Logical functions are functions such as if, and, or. Let's look at each one of them one by one and see how such logical functions are used for the purposes of financial modeling. In the first example before us, we can see labels such as construction start date, construction end date, construction start flag, end flag, on flag. What does this mean? Often in financial models, the construction period has to be distinguished from the operation period, which generally follows or is followed by the end of construction period. To mark or to create a flag, if you will, out of such difference in periods, we use an if function. As you can see in cell F, F12. F12 has been marked as the construction start date. F13 has been marked as the construction end date. In rows 4 and 5, we can see the start date for a particular period and the end date for the particular period. If I had to manually create a construction period, and the construction period should be marked by ones or zeros, what we would simply do is, let's say the construction date is starting at 1st April, so I'll go to 1st April, select a 1, and it is ending at 31st March 24, so I'll keep putting 1s till 31st March 24. This is the construction period. And if you see, row 17 is the exact same output. Now, how can one automate this and use Excel to do that task for you? Let's do it using the if function. The logic that flows is, first we create a flag for whenever the construction starts, is equal to if this particular date, which is the construction start date, is greater than or equal to the start date of a particular year, 1, otherwise 0. Let's change this formula to say only if the construction start date is equal to the start date of a particular year, then the value should be 0. Let's copy this formula all across, change the formatting. Now we can see that the construction start date is marked by a 1 in the second year, which starts from 1st April 17. Similarly, we can achieve the construction end date flag by putting an if condition. This date is less than equal to the end date of a particular period. Let's close this bracket. Let's add the condition that if this value is true, put a 1. If the value is not true, put a 0. Enter. Let's copy this formula. Copy the formatting. Now you can see that we are through with the construction start date flag and the construction end date flag. What now we simply want to do is create a construction timeline or a construction period flag using the above two. We can do that using a simple algebra formula, which is equal to construction start date plus the previous period minus construction end date. Let's copy this. We need to amend the formula for construction end date to make it equal to the year end for a particular year. And now you can see that the construction period has been formed from the start date to the end date. However, if we want the construction to end on the last day in the year which the construction flag ends, we can amend our formula by saying construction start plus last year's flag minus last year's construction end flag Let's copy this. And we have the construction on flag just like in the outputs. To recap, let's delete all of this. An if function has 3 arguments. The first is a logical test. So if 2 is less than 1, say OK. Otherwise, say not OK. Now, since 2 is not less than 1, we will get a not OK result. However, if we change this to, let's say, 5, we will get an OK. An if function allows us to test a particular condition and give a true or a false. Now let's move on to the second type of logical function, which is AND. Like you would have observed in the above formula, for construction start flag and construction end flag, we said that the years were supposed to start, construction start was supposed to happen on the first day of an year, and similarly construction end was supposed to end on the last day of a year, but this might not be the case in a real life example. Consider the example before us, where the construction start date is 25th July and the construction end date is 13th Jan. 25th July falls in which year? Let's see. 25th July 2018 would fall in year 3. Similarly, construction end date will fall in the year of, let's put 1 for all the years in which construction is happening, and this is the last year of construction. So we put a 1 in the last year of construction. If you look at row 29, this is exactly what we want to achieve, the construction on flag. Let's try to automate this using the AND function. We delete this. First, we use the AND function to determine the construction start flag. So the first condition is my construction start date should be greater than or equal to the start date of a year, and the construction start date, let's make it a relative reference where we fix only the row, only the column, here too only the column, so that we can copy the formula. Yep. And my second condition is that the construction start date should be less than or equal to the end date. Let's close the bracket. The AND function gives us a true or false value. As we learned before, to convert a true or false value into ones or zeros, we can simply multiply the entire formula with a 1. Here we go. Let's format it. And we have the construction start flag. Similarly, for the construction end flag, let's copy this entire row below and change. Rather, we would not be required to change anything because we have already achieved the desired output by the function. Let's go through the function. Construction end date should be greater than or equal to the start date of a particular year and should be less than the end date of a particular year, which is why the construction end date falls in the year 8. Let's prepare a construction flag, just like we did in the above example. Construction start plus the previous year minus previous year's construction end. Let's copy this formula, and here we have the construction on period. This was the AND function. Let's go a step further to calculate, as the output is in row 31, which is proportion of the year for which construction is on. How can we do that? Compute proportion of the year for which construction is on. Let's look at the logic. For years in which the construction start date is starting in the middle of the year, the way to compute the proportion of the year will be is equal to construction start date minus construction minus the year start date. Let's put both of them in a bracket, divided by the year end date minus the year start date plus 1. The plus 1 is to ensure that the year has 365 days. Instead of the start of the year, we'll put G5. Resume from proportion of the year. To compute the proportion of the year for which construction is on, let's look at the logic. As you can see, the construction commences from 25th July 2018, which is approximately 3 months after the start of year 3. If we had to compute the proportion of construction during that year, we would simply compute the number of days for which the construction happened in that particular year. To compute the number of days, we will simply subtract the end date of that year minus the construction start date, which is 249. Now let's compute the total number of days in that particular year, which is end date minus start date plus 1, so that the year has a complete 365 days. To compute the percentage, we simply divide the first figure by the second figure and convert it into a percentage term, and we have the percentage construction during that particular year. Keeping this logic in mind, let's look at the if formula. The if formula says, if my construction is commenced, which is H27 is equal to 0, end of year minus construction start date, which is this formula, which we've already covered, divided by end of year minus start of year plus 1 to give the total number of days, which is 365. The second part of the formula is if H28 is equal to 0, which means that the construction is ending in this particular year, F25, which is the construction end date, minus the construction start date, minus the year start date. So construction end date minus that particular year's start date divided by the total number of days in that particular year. And if neither of the conditions are there, then consider the value as 1, which means 100%, into H$29 is to ensure that we are computing values only for the construction on period, which is how we arrive at these values of percentage of the year which was under construction. Now let's move on to OR. OR function here, construction start date in this example, construction on flag in this example, and operations on flag in this example are much similar to what we've seen before. The formula before, the example before us asks us to create a flag for the periods in which we are either in the construction phase or in the operations phase. So let's focus on row 51 in this example, where we are considering ones for all periods of construction plus operation. Let's look at how we can achieve it through OR. OR, the description of OR is, OR checks whether any of the arguments are true and returns true or false. Returns false only if all arguments are false. In Excel, 1 is represented by true, and we can say vice versa. Similarly, false is represented by 0 or vice versa. Like we saw, if evaluates a condition and returns a positive, a true value or a false value, and evaluates a condition and returns true only if the value is true. OR, on the other hand, returns true if any of the values are true and returns false if all of the values are false. So in the case above, OR H45, which is the construction on flag, is equal to 1, or the operations on flag is equal to 1, then give me a 1, else a 0. So as you can see, in years of construction or operation, the flag is equal to 1. However, in the last period, where there is no construction or operation, OR returns 0. This was the OR function. Now let's go to if and OR. The example before us asks us to create a flag formula that returns a 1 if the construction period flag is on and either factory A or factory B flag is on. So let's use if and OR, all of them simultaneously, to create this output. Let's go through the formula once. If and H58 is equal to 1, or H60 is equal to 1, H61 is equal to 1, give me a 1 or a 0. All of that sounds very complicated. Let's break that down into simple words. What we want is, if the factory or if the company is under construction period, that is the first criteria. And the second criteria is, if either of the factories are running, or basically their flag is on, then give me a 1, otherwise give me a 0. So in cases where there is no construction happening, the flag will automatically turn to 0. In cases where there is no construction happening and either of the factories' flags are on, then too the flag will be 0. In case where the construction period is on, however, both of the factory flags are 0, then too the flag will be 0. For all the balance cases, the required flag will be 1. Let's try to model that function. Is equal to, and construction flag is greater than equal to 1, comma, or factory A flag is greater than equal to 1 or factory B flag is greater than equal to 1, give me 1. Otherwise, you might have noticed that after one round bracket, I put another round bracket just to close the OR function first and then the AND function. Then we are back to the if function where we use a comma to say 1 if the value is true, another comma, and 0 if the value is false. Now let's copy this formula and we have the desired output as per the examples asked. Moving on to the last of the logical functions, or rather second last of the logical functions, which is NOT. The example before us asks us to create a flag for all periods when construction is completed. Now, as you can see, the first 3 rows are similar to what we've done before. We have created a construction on flag out of the provided dates. What we want to achieve now is for all the periods when construction is completed. So if you think of it logically, we want to tag or flag all the periods other than the construction periods as a 1. How can we achieve that? We can achieve it through a NOT function combined with a SUM function. Let's look at how we can do it. Let's first understand how a NOT function works. A NOT function simply converts a true value into a false value, or a 1 into a 0. As we can see in this example, in row 75, we have the construction on flag. If we simply convert or flip, and in the years after the construction on flag, all of the figures are 0. So let's use the NOT function to convert the 1s into 0s and the 0s into 1. Let's copy this formula across. And here we are. For all the years after the construction on period, we have converted them into post-construction periods by using the NOT function. You might observe that the formula in the sheet provided to you is different from what we've just seen. The formula achieves the same result, only that it refers separately to the construction end flag and the construction on flag using the AND function. For years up to year 3, which is the construction end period, the AND function returns a 0, because of which we get a 0 value. However, right after the construction end period that is, we start getting a 1 for all the AND functions, which is why we are able to get the same result as we have in the row below. Let's move on to the last of the logical functions, false or true. The example before us asks us to create a function using true or false and to check whether a certain date falls within the current period. If you look at the formula, the second part of the formula is very similar to what we did in the AND function. We use the AND function to calculate whether the particular date falls within the start and the end date of the year. Now, if you observe the first part of the formula, it is getting multiplied by true. A true multiplied by another true will give us a 1. So if you scroll your cursor, scroll your selection to column K, you will see that the date 17th August 19 is falling in between 1st April 19 and 31st March 20. So the AND function returns a true. Since we're multiplying true with another true, it returns a 1. Similarly, in the row below, a true multiplied by a false gives us a false. Just like 1 multiplied by 0 gives us 0. So in this case, since the AND was evaluated to a true, however we were multiplying it by false, the result was a false. Often the logical functions are used whenever the logical functions are modeled, they return their outputs in true or false formats. To convert them into numbers, we can either multiply them by a true or a false, or simply multiply it by 1 to get a 1 or a 0.